In the last video, I showed you many different ways to get maps from a stream. There's one more intermediate operation I want to cover before I finish this streams section of the course, and that's the flat map. The flat map intermediate operation performs one-to-many transformations on elements in a stream pipeline. It's called flat map because it flattens results from a hierarchical collection into one stream of uniformly typed elements. On this slide, I'm showing the flat map operation next to the map operation with some of the generic typing removed for clarity. You can see these operations look very similar. The difference is in the return type of the function. For map, you return a different instance of an object. In this case, you're exchanging one type for another for each element on the stream. For flat map, you return a stream, which means you're exchanging one element for a stream of elements back. Let's see why this is a big convenience and examine it in the context of some code. I'm still using the Streaming Students project and the main mapping class from the previous video. I've finished off my code in the last video with several different maps of the students I generated. I have a map of country code with lists of students in each of those buckets. I have a bifurcated map partitioned by a Boolean value with true representing experienced students. I also have a map of nested maps. The top level key is country code and the second level is gender. Now let's imagine this is how the data was delivered to us. It might have a couple of elements, or it might have many millions or even billions of records. Let's start with counting how many elements we've got. First of all, you don't want to use streams for functionality that can be easily deduced without them. Let me show you an example of this first. Let's say I'm a new developer and I just really like streams, and I'm going to use them everywhere. I'll set up a new local variable along called student count, and I'll use the count terminal operation on my students by getting a stream first. Notice that IntelliJ has highlighted the count operation. Hovering over that, I get the message that this can simply be replaced with collection.size. Why would I use count on a stream when I can just use the size method on the students list? Sometimes it's easy to forget what's a stream and what isn't. So luckily for us, IntelliJ gives us reminders to pay attention. I'll revert the code, removing that last statement. But let's say I'm getting the data in the experienced map from a method, and I want to know how many students are in it. Getting just the size of that is just going to give me 2 because I have 2 keys in my map, true and false. I could get the count by looping through the values in my map and accumulating the counts from the sizes that way. I'll add that just for clarity, pretending we don't know the size. I'll set up a variable that will keep a running count, student body count, and initialize it to 0. I'll loop through the values and add the size to my student body count, finally printing it out. This code gives me the right count, which of course we know is 5,000. How would I go about getting the count of students who've been active in the last 3 months using streams? That's a little more difficult to answer. First of all, maps don't have a stream method, so you have to pick a view to stream on. This could be the keys or the values or the entries. Let's first count our students in the map using streams without filtering. Doesn't this appear fairly straightforward? Pause the video here a moment and give that a try on your own. Were you able to figure that out? It's not as straightforward as you'd expect. If you tried to use count, you probably figured out that it's hard to get a number other than 2, the 2 elements keyed in your map, even if these are lists. I'll use the sum operation on intStream to do this. I'll reassign the value I get from my pipeline to the student body count. I'll call map to int and map each value to an integer, the size of the students in that keyed list. I can use sum because I now have an int stream. I'll copy line 64 and paste it on line 69. Running this code. I get the right number of students, 5,000 for the result, and that wasn't too awful, was it? Personally, I like this better than the for loop above it. Just for the record, for the rest of this video, I'm purposely going to ignore IntelliJ's hints to turn lambdas into method references. I feel like this code will be complex enough without adding that extra level of indirection. Okay, now the question is, how would I filter my students by an attribute on student in this code? At no time do I have a stream of students on which I can act. Because map is one-to-one, I can only examine the collection or list of students as a whole or transform them into another singular unit. What if I mapped to a stream? I'll try that next. I'll make a copy of lines 66 through 69 and paste that on 71. I'll insert an extra map operation above map to int. I'll return a stream from the list of students I have here. First of all, this doesn't compile, but let's ignore that for a moment and examine IntelliJ's inlay hints. Notice what I get back from the map operation. I don't get a simple stream of students, I get a stream which itself has a stream of students. It's really still a one-to-one exchange. I'm still getting one element back, it just happens to be a stream. I get an error on the map to int operation because stream doesn't have a size. I can use this stream though to reduce the elements in the stream to a single value and even filter my students here. Let me show you that. First, I'll add a new line after the call to stream. I'll add a filter. Here, I only want students who have been active in the last 3 months. I'll use count to return how many there are. I still have a problem with map to int. Here, I really want this to be mapped to long, since that's what I get back from the map operation. Now I can just return the value on the stream, which is a long. That compiles and runs. I do get a count for the number of students who've had some activity in the last 4 months. I don't know about you, but this code feels convoluted and ugly to me. Imagine now if I wanted the same information, but for a map like my multi-level map. I'm not going to code that. I think you've got the picture. What I'll do now is do this same thing, but use the flat map operation instead. First, I'll set up a local variable, a long call count, and I'll assign that the result of this pipeline process. I will start the same way with experience.values.stream. I'll call flatMap rather than map and get a stream from each of my list values. I'll filter as part of the main streams pipeline. I'll use the terminal operation count here, and I'll print the value I get back. Before I run this, let's examine the inlay hints again. Notice what comes back from flatMap. My stream, which contained a bunch of lists, now contains students instead, and not a stream of students. This means I'm getting back not just one element, but instead this could be 0 to many elements back, and all knitted together on one stream. This operation is called flatMap because I've flattened my tree structure into a simple list of students. It feels a little backwards sometimes because you're getting many elements back, but think about it as flattening the hierarchy of your source data. If I run this code, I get the same results as before as I did from the uglier map example. Now I'll try to do this for the multi-level map. I'll copy that last bit of code, everything but the long type there, and paste it. I'll change experienced to multi-level. In the flat map operation, I'll change the variable L to map, so it's a bit more understandable, and I'll change L.stream to map.values.stream. This code doesn't compile, and if you look at the inlay hints, you can see coming back from the flat map operation, I don't have a stream of students. I have a stream of lists. I haven't flattened this enough. I can do this one of two ways. In the flat map operation, I can keep processing my flattened stream a little more. After the call to map.values.stream, I'll include a new line. Here I'll make a call to flat map on this new stream. These are really lists, and I can get a stream from them, making a call to flat map on this nested stream. This fixes my compiler error, and I can run this code. I should get the same number of active students as I did in my experienced map. It's still ugly though, but actually I can streamline this code even more. I'll leave this the way it is, and again make a copy of it, pasting that copy below so you can see both versions. I'll add a parentheses to the end of line 95, then delete line 97, and fix the formatting on line 96. That looks a lot nicer and is easier to read. If I run it, I get the same results as before. The flat map operation allows us to use a single pipeline stream to do all our processing instead of nesting stream pipelines as I had shown you previously. Okay, so I hope that made sense, and you can see why you'd want to use this operation if you're dealing with structures of nested data. I have one final challenge for you in this section of the course, and it'll be one more challenge on this student demographics data. I'll see you in that next video.